Alright, so more with polar coordinates. In this video we're going to talk about how to convert between rectangular coordinates, so x comma y's, and polar coordinates, again our r comma thetas. So let's take a look at how polar coordinates and rectangular coordinates are related. So coordinate conversion, that's what we're going to be talking about today. So r comma theta is related to x comma y as follows. So let's take a look at a graph here, and let's put a point out here in the first quadrant. So there's two ways that we can get to this point. I can either go this direction first, so that would be x, and then I could go up in my y direction, so that would give me my x comma y, and I'm going to connect this here. So that's how I would get to that point using xy coordinates. If I was going to do it using polar coordinates, I would figure out what circle I'm on, so I've got some circle that I would be part of, and then I would go out to that circle and then rotate theta. So that would be my directed distance, theta would be my directed angle, and you can see what we end up with here is a little right triangle with x, y, and r. That should look familiar to you. So we're actually just going to use right triangle trig to find the relationship between polar coordinates and rectangular coordinates. So if I look at the cosine of theta here, so the cosine of theta, it would be x over r adjacent over hypotenuse. And then if I solve this for r, just put this over 1, cross multiply, I would get x equals r cosine theta. Okay, so this gives me a relationship between the x coordinate and r and theta. So if we do the same thing with sine, the sine of theta, that would be y over r. Again, I'm going to put this over 1 and cross multiply. I would get y is equal to r sine theta. So this gives us a relationship between the y coordinate in rectangular and r and theta in polar. Okay, so let's write these down. I've got x is equal to r cosine theta, and y is equal to r sine theta. So this is going to be one of our conversions, and we are going to use to convert to rectangular. Okay, so if I'm given r and theta, I can substitute them into these formulas here and figure out what I have for x and y. Alright, so how about going the other direction? Again, using some right triangle trig, if I wanted to find the angle theta, one way that I could do it is I could do theta is equal to the tan inverse of y over x. Okay, if you remember back from when we did our trig unit. Solving for angles, we did tan inverse. So really what I'm starting with here, if you remember what I'm starting with here, is tangent theta is equal to y over x. And then if I wanted to solve for theta, I would just do the tan inverse of both sides, and then I would end up with this. So I've got theta equals tan inverse y over x. So if I've got y and x, I can find my angle, again just using right triangle trig. And again, if I have x and y, remember we have a right triangle up here. If I have x and y and I want to find r, all I have to use is the Pythagorean theorem. So I know that r squared is equal to x squared plus y squared. So here are our two formulas for converting to use to convert to polar. Alright, so again, if you know y and x, you just do tan inverse y over x and you get theta. You do x squared plus y squared, remember to take the square root at the end, and you get your radius. In the next video, we'll look at some examples of each. If you have any questions, make sure you ask them, and we'll see you in class.